Okay, we're going to simplify this expression. We have a parentheses 8x to the 3/2 power, y to the negative 6 power, and then o raised to the negative 1/3 power, and then o over x to the 1/4 power. As long as we follow the order of operation with the exponents, we can make this happen. And all we do first is take care of the parentheses. Notice that the inside, they're all multiplying. It's 8 times this times that, right? Therefore, I can just take this exponent and then like distribute the exponent inside like this. And once again, we can do it this way because everything inside is multiplying. If there's like addition or subtraction in between, we cannot do this. Alright, so this will be the first step. And let's see what we get. We will first have a to the negative 1/3 power. Just let me write it down like this. A to the negative 1/3 power. And we'll fix the negative exponent in a second after we finish with the rest. Next, we have x, okay, to the 3/2 power and then raised to the negative 1/3 power. What should we do with the exponents? Well, in this situation, we will multiply the exponents together, multiply the powers together. So, we will have to work out 3/2 times negative 1/3. So let me just put it down, negative 1/3, like this. And the question is, what's 3/2 times negative 1/3? Well, the 3 and 3 can be cross-reduced. And then at the end, it's pretty much just negative 1/2. And that's all we have. That's a new exponent for the x, negative 1/2. How about for the y? We have y to the negative 6 raised to the negative 1/3. The base will stay the same. Let me put it down to y. And then in this case, we are just going to multiply the exponent as well. Take negative 6 and we multiply with negative 1/3. Well, let's just multiply. Put this as negative 6 over 1 if you would like, and we can cross reduce. 3 goes into 3 one time, 3 goes into 6 two times. Negative 2 times negative 1 is positive 2. All over 1 times 1, which is 1. So we have positive 2 for the y. Okay? And then all over x to the positive 1/4 power on the denominator. Right, and this is what I would like to do next. I'm going to keep this and keep that. I would like to just fix the x to the negative 1/2 over x to the positive 1/4. Because they have the same base, we need to figure out the new exponent. Let me just keep it as how it is. So let me write it down. 8 to the negative 1/3 power. And let's figure out the new exponent for the x. So let me put down the base. And what do we do in this case? Whenever we are trying to divide, what should we do with the exponent? Well, in that case, we subtract the exponent. We take the top exponent, in this case is negative 1/2, and then we subtract the bottom exponent, which is positive 1/4. Okay? And in this case, what do we do when we are trying to subtract fractions? Well, we need a common denominator. The common denominator in this case will be 4. So that means for this one, I need to multiply by 2 on the bottom and on the top. So I get negative 1 times 2, which is negative 2, over 2 times 2, which is 4, and then minus 1/4. And altogether, the denominator stays the same, which is 4. Negative 2 minus 1, that will give us negative 3. So that's the new exponent for the x, negative 3/4. And then y squared, once again, stays the same, y squared. Okay? Alright, are we done? No, because we have to fix the negative exponents now. Whenever we have negative exponent, we bring the whole thing down to the denominator and then make them positive exponents. So we are going to get, well, this is going to go down to the denominator. So let me just write it down. 8 to the positive 1/3 power. Okay. So is this. I also have to bring this down to the denominator. X to the positive 3/4 power. And then the y is y to the positive 2. So it stays on the numerator, y squared. So this right here is how we fix the negative exponent. And at the end, we'll see how we can change this into a radical form. And this is the idea that we need. Whenever we have a fraction exponent, this is what we need. If we have a to the fraction power, let me write it down as m over n. Well, to change this back to the radical notation, we should first look at the denominator. Okay, so the over n. This right here will tell us we are doing the nth root. Okay, and then the inside is going to be a to the n power. Okay, so this is how you make the change. We'll use this right here and right here. So let's see. On the top, we know we have y squared, and then over, what's a to the 1/3 power? Well, based on the idea we just talked about right here, the 1/3 power, the over 3, is the same as saying we take the cube root of the number 8. Okay, and how about this one? Well, we have to take care of the fraction power, the denominator, which is the over 4. This over 4 tells us that that's the fourth root. So I'll put down it's the fourth root. And then we will have x to the 3rd power. Okay, so this is the change. Well, is there anything else that we can do? Yes, we can. Finally, we see that, okay, on the top is just y squared, that's okay. Over, what's cube root of 8? Well, what times 4 give you 8? 2, right? Just a nice number 2. And this right here is fourth root of x to the 3rd power. And this right here will be the final answer. Okay, that's it.